In this video, we're going to learn dimensional analysis, which is a method in chemistry used to solve quantitative problems. So this is going to be the technique that we're going to use for any kind of unit conversion. And it'll be really, really helpful once you get the hang of it, because as the problems get longer and more complex, you'll be able to do any kind of unit conversion. So we'll start with a one-step conversion, which are the simpler, easier problems, and then we'll gradually work our way toward more complex examples in subsequent videos. So the first problem is asking us to convert 175 pounds to kilograms. And the first thing I do is identify what is given to me in the problem and what we are trying to solve for. So here we are given 175 pounds. That is what we know. And what we're trying to figure out is how many kilograms that will be, which means that we need some way to connect pounds to kilograms. We need a conversion. And 1 kilogram is equal to 2.2046 pounds. That is a value that we could look up in a textbook or an exam reference sheet. That is an equality. That is relating pounds to kilograms. Anytime you see an equality, so anything with an equal sign, you can turn that into a conversion factor. And a conversion factor, you're basically going to separate those two units with a line. So we could say that in 1 kilogram, we have 2.2046 pounds. Or we could flip that upside down. We could put the pounds up top and kilograms on the bottom. So these are both conversion factors. They are both correct. They are equal. They are equivalent to each other. The only difference is which unit is on top and which one is on the bottom. And we do want both versions because you'll use either or depending on which unit you're trying to end with. And whenever I'm doing a dimensional analysis problem, I always start with what's given to me. And here in the problem, we are given 175 pounds. So I'm going to start there. And then I'm just going to multiply this by a conversion factor to get to where I'm trying to go, which is kilograms. Now, the unit that we are trying to end with is always going to have to go up top. So I do want to end in kilograms in the numerator. And the unit that we are trying to cancel is always going to have to go diagonally from where that unit was to begin with. Now, notice that here pounds are up top, which means that in order to cancel them, we need to put pounds on the bottom diagonally from the pounds that we started with. And the only conversion factor that we have listed that matches these requirements is the conversion factor on the left, because that puts pounds in the denominator and kilograms in the numerator. So I'm going to use that version of the conversion factor. I'm going to put the 2.2046 pounds on the bottom and 1 kilogram up top. So now that the pounds are diagonal from each other, they're going to cancel out. Now, sometimes students get a little bit confused because the conversion factor on the right here is a fraction, but then the unit that we started with doesn't have anything in the denominator. So what you could do is put a 1 there as a placeholder, because when you multiply or divide by 1, you're not going to make any kind of difference. Alternatively, you could leave it out if you don't mind there being nothing there. That would also be fine. Okay, so now we have our setup. The pounds are going to cancel out, which means that the solution is going to be leaving us with kilograms, which is what we're trying to find. And in dimensional analysis, everything in the numerator is going to get multiplied, and it's going to get divided by everything in the denominator. So if we had left a 1 here, we would just be dividing by 1, which is not going to make a difference in the result. So really what we are doing is dividing 175 by 2.2046. Now in this kind of problem, that's very simple, and it seems a little bit redundant of why we are doing this whole process. But as the problems get longer and more complex, it will become very, very helpful to do the calculations in this type of format. Okay, so if I plug that in, I'm getting 79.4 kilograms. And make sure that you are always leaving units in all of your calculations and all of the answers. So every number should have a unit attached to it. Okay, let's try another one. So sometimes the dimensional analysis problems will come in a word problem format. So this is telling us that one tablet contains 325 milligrams of ibuprofen, and it's asking us to find how many tablets will supply 975 milligrams of ibuprofen. So the first thing I'm going to do is find out what we are given and what we're looking for. So here we are given, and given will always be the number that's off by itself. It's not a part of a conversion. So we're given that we need a dosage of 975 milligrams. So that is the dosage that we are trying to supply to a patient that is taking this medication. And what we're trying to find is how many tablets we need to give this person in order to supply 975 milligrams. So really what we want is the number of tablets, which means we need some way of converting between milligrams of ibuprofen and the number of tablets. And that is going to be a conversion factor that's also hidden here in the problem. It's telling us that one tablet contains 325 milligrams of this medication. So really that's an equality. It's saying one tablet is equal to 325 milligrams of ibuprofen. And anytime you have an equality, you can turn that into two conversion factors. So we can start by putting a tablet on top and 325 milligrams of ibuprofen on the bottom, which I'm just going to abbreviate. Or alternatively, we could flip that upside down. We could put the 325 milligrams of ibuprofen up top and one tablet on the bottom. And whenever I do a dimensional analysis problem, I always start with a number that's given to us and a number that's not part of a conversion factor, a number that's just off by itself. Which means I'm going to start with 975 milligrams. Okay, so what we are interested in finding is the number of tablets, which means that that's what I'm going to have to end with up top. And the unit that I'm trying to get rid of is going to have to go on the bottom here. And the unit that I'm trying to get rid of is the milligrams. We're not interested in milligrams. We're interested in the number of tablets, which means I'm going to look at my conversion factors. And it so happens that the one on the left is, again, the conversion factor that we need. Not always the one on the left, but in this case, milligrams are on the bottom, and that is what I want to put in the denominator. And in 325 milligrams of ibuprofen, well, that will be equivalent to one tablet. So now the milligrams of ibuprofen cancel because here milligrams are up top in the numerator, here the milligrams are on the bottom in the denominator, and they are diagonal from each other. So they're going to cancel out, and we are going to be left with a number of tablets when we solve the problem. So I'm dividing 975 by 325, and that's getting me 3 tablets. So we would need to administer or give this person 3 tablets in order to give them 975 milligrams of ibuprofen. Let's try another one. This problem is saying that a car is traveling 80 kilometers per hour. Anytime I see the term per, or anytime I see a slash like this, I'm going to immediately convert that into an equality. Because really this is saying that a car is traveling 80 kilometers in 1 hour. So these are equivalent to each other. That is an equality. And anytime you have an equality, you can turn that into 2 conversion factors. Which means that in 1 hour, the car is traveling 80 kilometers. Or I could flip that upside down and put 80 kilometers in the numerator and 1 hour in the denominator. The next thing I'm going to do is identify what is given and what we are looking for. So we are given that this car is going to travel 400 kilometers. And what we're trying to find is how many hours will it take to travel 400 kilometers. So we want the number of hours. I'm going to start with the given, so 400 kilometers. And then I'm going to multiply this by a conversion factor so that I'm ending in hours. And since we want the number of hours, that's the unit that's going to have to be up top. And the unit that we're trying to cancel, which is kilometers, is the unit that's going to have to be on the bottom. And if I look at that left conversion factor, that's where the kilometers are on the bottom and hours are up top. So that's the version I'm going to use. So there are 80 kilometers, 1 hour. And here I see that kilometers are across from each other, so they cancel, which really means that what we're plugging into our calculator is 400 divided by 80. So that will give us 5 hours of travel to go 400 kilometers. Let's try one more. This one looks maybe a little bit more intimidating because there's a percentage in there, but I'll show you a trick for handling that. So this is saying that a patient has 18% body fat by mass, and if the patient weighs 73 kilograms, how many of those kilograms will be actual body fat versus everything else in their body? So again, I'll start with what's given and what we are looking for. So the patient weighs 73 kilograms. We have the patient's weight or mass. And here I'm going to be very specific because this is telling us that their entire body mass is 73 kilograms. And what we're looking for is out of those 73 kilograms, how much of that is actually body fat? So here you really want to be specific about what you are referring to, because notice that both of the units are kilograms. So if you're not specific and you're not indicating what you mean, it's going to look like units cancel when they actually don't. So you want to write more than you would actually really like to. These things can get a little bit wordy. Okay. So we need some way of connecting body mass to body fat, and we're given a percentage. So this is saying 18% of that body mass is actually body fat. So what you could do is, we know that in order to get a percentage, we are dividing parts by a whole. And if we were to set the denominator to be, let's say, 100 kilograms, this really means that 18 kilograms of that body mass are body fat. And if you were to multiply that by 100 to get a percentage, we see that the hundreds are across from each other. They're diagonal, which means they cancel out. And we're getting 18 is equal to 18. So anytime you see a percentage, you can immediately make the denominator 100, and then whatever the percentage is equal to is going to be in the numerator. So this automatically gave us a conversion factor that we can use. So here I have the 100 kilograms of body mass on the bottom and 18 kilograms of body fat up top. I could also flip that upside down. So I could put 100 kilograms of body mass in the numerator and 18 kilograms of body fat in the denominator. So we have our two conversion factors, and we're going to set up the problem just like everything else that we have been doing. So I'm going to start with what's given, and that's 73 kilograms of body mass. And then I'm going to have to multiply by a conversion factor. We're looking for kilograms of body fat. which means that that is what we're going to have to end with up top. And we want to cancel the kilograms of body mass, so that's going to have to go on the bottom. And the conversion factor that matches that is the one on the right. This has kilograms of body mass in the denominator and kilograms of body fat in the numerator. So that's what I'm going to enter here. And notice that we have to be very, very specific with what we mean, because if I did not indicate body mass here, it looks just like kilograms. It all looks like just kilograms. So it looks like everything here cancels when it actually doesn't. So you do want to include what you're referring to, because kilograms of body mass and kilograms of body fat are not the same thing. So now we have kilograms of body mass in the numerator and kilograms of body mass in the denominator, so those are going to cancel out. So what we're doing is multiplying 73 by 18 and dividing by 100. And that will get us the final value. And the unit that we're going to be left in is kilograms of body fat. Okay, so we're getting 13 kilograms of body fat. So out of those 73 kilograms of body mass, only 13 are actually body fat. So that's the only trick to these percentage problems. Anytime you see a percentage, make the denominator 100, and then the numerator is exactly equal to the percentage.